So this is going to be the parent function and point discontinuity. Parent. Under this flap is going to be the roots. Under this flap is going to be the asymptotes, specifically the vertical ones. You heard me. The t squared is going to be two things. It's going to be tangency, which we've already talked about. This is bounce, and togetherness. E is the end behavior. And that's going to be our horizontal and slant asymptote. And under this one is the y-intercept. So under the first flap, it's going to say, does it have a parent? So that's going to be the parent function of the rational or the reciprocal is 1 over x. And that graphs, we already did this like this. It has the asymptotes at x and y equals 0. And we had the anchor points of 1, 1 and negative 1, 1. And we shifted back and forth and up and down, and we did stretches with those points. We also have this, which is also going to be a form of our parent function. And all this is going to do, I'm going to keep this branch here, but the other branch would flip up, and they would go together. And that would be our togetherness. And that's when you get an x squared term on bottom. So if we get either of those, we're just going to do the transformations. Okay. None of what we do is going to be just transformations. So we're past that. So the point discontinuity, we talked about this. This is when the factor contains x that is common to the numerator and denominator. This is our cancel term. Okay, roots are the x-intercepts, which are the zeros of the numerator. And we find it after we reduce. The only thing we find before we reduce is the domain. The bottom is the vertical asymptote, and that's going to be the unique factor containing x in the denominator. What? It's a line determined by the zeros of the denominator. Okay, so basically the roots are on top. The roots are on top, and the zeros are on bottom. So the roots are on top, the zeros are on bottom. Okay, so we're going to come back to the tangency and togetherness. So we're going to talk about the horizontal asymptote and the slant asymptote next. If it's Mason, what do you get for a horizontal asymptote if it's top heavy?
0, 1, none.
Bottom heavy is y equals 0. If it's tied, it's y equals the ratio of the leading coefficient. We get a slant asymptote or an oblique if the degree of the numerator is 1 greater. You guys can't mind read? Jeez. 1 greater than the degree of the denominator. We're going to divide it and ignore the remainder. The last one on the bottom is the y-intercept, so we're going to substitute 0 for x and solve for y. And it's written as an ordered pair. So go back up to the top. So the tangency and togetherness. Okay, so first of all, the tangency comes if you get a term that's squared on top. And so you see where it has the parentheses and it's x minus 3 squared? So it's not this. So that x squared is not tangency because it's not a whole term squared. Okay? You need a whole term squared to get tangency. So this one is going to give us tangency, and this is a bounce. And we already did these when we did the polynomials. This is where it comes and touches and it goes right back up. It doesn't cross. It happens when you have an even exponent on the top or the bottom. Bless you. So if the squared term is on bottom, this is togetherness. So this is going to be around an asymptote, and they would have to go towards the asymptote together. Okay, so we're going to use that when we graph. There you go. Super cute, nice, fun little foldable. You're welcome. No, you may not get on your phones yet. All right. Okay, so here's what I want you to do. What's the only thing that we find before we reduce? Is domain even listed here? It's not even listed. I took it off the list, so you're not even confused. So the first thing you're going to do every time you start a graph is you're going to factor and reduce. So all of you factor, reduce, and start filling in what you know. All right, so how do we factor on the bottom? Okay. So when I factor like that, then what happens? So I'm left with 1 over x minus 3. That's my reduced function. So I set x plus 2 equal to 0. So my x is negative 2, and that's a canceled term, so that's a point discontinuity. So I'm going to find f of negative 2, which is going to be 1 over negative 2 minus 3, which is negative 1/5. So next, where do the roots come from? The roots do not come from the bottom ever. Top. From the top. But what's on top? 1. So there's no x. So this tells me that my graph is not going to touch the x-axis. So what's probably going to be on that axis if we don't have any intercepts? Probably an asymptote. So the vertical asymptote comes from where? Bottom. So I get x is 3. I don't have any tangency or togetherness here. I'm bottom heavy. So y equals 0, which means no slant asymptote. And my y-intercept, I find f is 0. So I get 1 over 0 minus 3, which gives me a negative 1/3. So on the number line, we're going to put the roots and the vertical asymptotes. So the only thing on the number line is 3. So I'm going to start by putting the whole here. So I have negative 2, negative 1/5. So there's right there. And I have a y-intercept is 0 and negative 1/3. So that goes right here. So next, I'm going to put x equals 3. And y equals 0. So why do I put the roots and the vertical asymptotes on the number line? It is to test it. But the reason we test it is because those are the points where the function is going to change from positive to negative. And on all of the homeworks you did, not a single one of you ever noticed that if you get positive for the first one, the next one has to be negative. And the one after that has to be positive. And the one after that has to be negative. Always. So all of you that did them over and over and over and missed them, it was funny, but normally by now you all have caught on, but no. So that's why it changes. All right? So if you test the first one, you don't have to test the rest. But what you do have to do is you have to get it right. Because what happens if you miss the first one? You're going to miss all of them if you do that. The only time this doesn't work, well, it always works, but there's a twist to it if there's togetherness. Because it changes, because they have to both, we get 2 in a row that are the same. All right. So if I test right here, if I test 0, if I put 0, I get a positive over a negative, which gives me negative. So this is negative, so over here has to be positive. And you can test it if you don't believe me, but it is. Okay, so when I look at this now, so this tells me everything from 3 and back has to be negative. So from here back, it all has to be below the asymptote. So when I draw this, can this go above the asymptote? Because it has to be negative, right? Okay, so I don't have to test to see if it'll cross over there. So then from 3 on, it's positive, which means it's up here in this quadrant. So is it going to cross the asymptote? It's not, because that would be negative. So I know when I draw this, it's going to look like this. It's going to go here, here, and here. And this is all going to be positive. Thank you. Okay, fill out the list on the next one.
No, yeah, it's positive 2 because I forgot that. Yeah. But it'd still be
Okay, all of you stop. Because you are all being ridiculous right now. What cancels? Okay, so we're going to get a point discontinuity.
Oh, yeah.
right? You guys, what is left over? X plus 1. What is that if you graphed it? It's a what? It's a line. Does a line have a vertical asymptote, a slant asymptote, a horizontal asymptote? Does it have any of the stuff? No. You guys are like literally making stuff up.
We can't think like that.
You are.
We only have 2 brain cells.
You're clearly. So I am going to get a hole in the line. Right there. So from there, what is the root? -1. So the y-intercept is literally in the equation. It's a 1. Do I need to do a number line to draw the line? Yeah. You do it then, Mason. So before you plow ahead, look at what you have. All right, the third one, everybody factor. Okay, so everybody should have factored. The x minus 3 cancels. So I got, what? 7, 5. Work with it. Work with it, Mason. If I try to erase it, we'll add like 10 minutes to the lesson. All right, so 3. Okay, so where does 7/5 go? But below 2, right? So between 1 and 2, very good. So that's the hole right there. Okay, so next, the roots come from where? Top or bottom? Top. So what's left on top? So put a point at -4. The vertical asymptote comes from bottom, so I get x equals -2. So if I put that on the graph, there's my -2. I don't get any tangency or togetherness. There's no x squared left on top or bottom. Now, the horizontal or slant asymptote, is this top heavy, bottom heavy, or tied? Tied, so what does that equal? 1/1, which is 1. So I get none on the slant. So if I put y equals 1 here, so I'm going to test that right there. Put that right there. So next, I want the y-intercept, so I'm going to do f of 0. So I get 4/2, so I get 0, 2. So I'm going to go ahead and put that point on. So there's the point. So on the number line, I put the roots in the vertical asymptote. So the root, I have -4 and -2. So I'm going to test f of -5. So if I put -5, I get negative on top and I get negative on bottom, which means that's positive. So if this is positive and I don't have any tangency or togetherness, The next one is negative, and then positive. So watch. That tells me at -4, I want positive. So that's above the axis. So I think it's probably going to go here, but I have to see if it's going to cross the asymptote, because I don't know, because that's still positive. Remember the last time it couldn't cross the asymptote because that would go from negative to positive, and we knew it didn't. But this time, we don't know if it crosses or it doesn't. So we have to test to see if it does. So what is the value at y of the asymptote? What's the value? 1. Stop rolling your eyes. You act like this is hard. It's not. The value is 1. So we're going to take the reduced function. It's 45 at least. And set it equal to 1. That's like one whole step. So since I set it equal to 1, I'm going to put it over 1 because I'm going to cross multiply. This is like at least step 46 now. So when I cross multiply, what happens to the x's? They cancel, for those of you that are actually paying attention. So 4 equals 2. Does that even make sense? No. If you don't get an answer, it can't cross the asymptote. Because sometimes it's going to work. So, some of them.
It will?
Mm-hmm.
No, like it's not like when you test it.
Yeah.